Awesome. Cool. We are recording. Alrighty. So hello, everyone. I'm so glad that you're all here. Today, we'll be going over the basics of MATLAB and along with a quick introduction to just coding in general. If you guys haven't signed in, the QR code is on the screen. I can also drop the sign-in sheet into the chat one more time so you guys can sign in, but I'm going to go ahead and get started. Okay, so first I'm just going to cover the very basics. What is MATLAB? So MATLAB is a coding language that stands for Matrix Laboratory. Essentially, it's well known, it's called Matrix Laboratory because it's really good for matrix manipulation. So a lot of this sort of like matrix multiplication and other matrix related functions that are a little more challenging to do in another coding language such as Python or C are really much easier to do in MATLAB because it's made for that. It also has a lot of great functionalities to allow you to like plot and visualize your data, which makes both of these things make it really helpful for BMEs. We're often doing things that have to do with both matrix manipulation and data visualization. So because of that, it's commonly used in research and industry. For example, I currently work in a research lab where we work on neuroengineering related stuff, and my entire project is based in MATLAB. So definitely very useful skill that you will be using both here and now in like classes and probably even after you graduate. So I'm going to go over the MATLAB IDE. So IDE stands for Integrated Development Environment. And essentially when you're coding in a language, there's some languages that you can just kind of code on your computer and run on your terminal. So just run on your computer. But there are other languages that often require an IDE, which is essentially a software where you put your code in and it runs the code in that software, which is downloaded onto your computer. So MATLAB requires an IDE. So this is kind of a picture of the MATLAB IDE, which means that if you open up MATLAB, the app on your computer, this is generally what will come up. So, or understanding this makes it a lot easier for you to code and especially debug your code later. So on the left, we have the current directory, which is essentially where all your files are stored. And it's open to the folder you have open on your computer. This is really important because you need to be in the folder that has the code you're trying to run, or else MATLAB won't be able to run your code. So make sure you're on the correct folder in your current directory. That's usually like a quick and easy bug to fix in the beginning if your code isn't running at all for some reason. The editor is where you actually input your code. So as you can see here, this person has some code that they're running here. This is the program that MATLAB will run. So at the top of your screen, when you click run, this is what actually runs. On the bottom, what your results from your code will be outputted into this command window. You can also run like one-line commands in the command window, such as like entering arguments for functions and things like that, or entering user input. But generally, you should keep most of your coding. I would recommend personally to keep most of your actual coding up in the editor, because then you can save it, you can edit that program and use it later, and it's just like better coding practice, if you ask me. On your right-hand side, you have the workspace. So this is where when you create a variable, we'll learn what variables are later, but essentially they hold some piece of data. When you create any variable, you can see it on the right-hand side. It'll show up in this workspace as soon as you run your code. And it'll show up not only with the variable name itself right here, but it'll also show the value. So for example, this person who's running their code has some variable called answer that has this value of this crazy long string of characters, essentially. So that'll help you see if you realize that some of your variables aren't being generated or they're being generated and the values are all wrong, you can check that in the workspace like immediately. And then finally, the bottom right, some people, or if you choose to like enable it, you can have the command window kind of on your screen. And this just shows you a history of everything. This is a command history that shows the history of everything you type into your command window. There are ways for you to be able to save this as well, so you can like come back to it and refer to it later. All right, so now I'm going to pause. Does anyone have any questions right off the bat, like just like MATLAB and its organization? No? Okay, cool. So I'm going to keep going. At any point, if anyone has questions, I have the chat open or just interrupt me and I will be more than happy to answer questions because that's what I'm here for. But right now I'm going to go into the basics of just coding. So this is like not even MATLAB specific. Well, some of these things will be MATLAB specific, but in general, these are really common concepts that you're going to see in any coding language you pick up. I'm not sure how familiar you guys are with coding, but I'm assuming you guys are sort of beginners if you're here. The way coding languages works is that you have to your first language is the hardest because you have to learn like all these, like just the way code works. But then as soon as you learn that first language, every language you learn after that is pretty similar. So these are concepts that are going to be there in all coding languages that'll help you pick up new languages as you need to really quickly. So first we have the idea of a variable. So a variable is just a value that stores a given value at a specific memory location. So generally your variable is almost like, think of it almost like as a bucket, and you put things into this bucket and then you can carry your bucket around in your code and use whatever's in that bucket in different places. And you can change what's in your bucket, and your bucket has like a specific location. So like an address where you can point to that bucket. So that's what a variable is. They're super useful. Almost any coding or any code program you put together is going to have variables. Then you have comments. Comments are what explain your code. The computer does not read comments. When it sees a comment, it just skips right over it. But other programmers generally have no idea what your program is about. So it's really, really important to comment all the code you write so that other programmers just know what's going on. In MATLAB, this is specifically denoted by the % sign. So I have it right here. So as soon as you write the % sign, that line in MATLAB will just become green, and you can type in whatever you want. The computer won't read it. Then we have conditional. So a conditional is essentially what helps your program to do either like one thing over the other. For example, there a very basic type of conditional is called an if-else statement, where you might say like, if I'm wearing black today, it's a good day, for example. And you might have a program that outputs like based on the color you input, which would be like a character or a string, it would output like a certain output into your command window. So it could even be like, for example, if you have like a yes or no question, and if your user says yes, you might want the program to do something. If your user says no, you want the program to do something else. So that's how you code that into if-else statements. And these are a really basic unit in an if-else statement is a Boolean. So these are either true or false. Those are the only two values a Boolean can have. And so in an if-else statement, when you're trying to compare things, because you're trying to say if the user said yes, you might say if yes is true, and true would be a Boolean that essentially stands for a 1 inside of computer. Computers work in ones and zeros, which is like you guys might be familiar with. And essentially the way they convert that when you're coding is like true and false. And then finally, we have loops. So loops allow you to run the same bit of code over and over again. Often when you write programs, the reason computers are so efficient is because they run the same thing over and over again, often some piece of like computation or something that would be really difficult for a human to do. That's why we use computers, and that's why coding can be so powerful. So loops are the essence of that. There are two types of loops that you'll probably end up using. While loops let you repeat code until a condition is reached. For example, if you want to repeat your code until the user inputs yes. So you keep going and you ask the user questions again and again, and you have to keep going until they answer yes to your questions. You would use a while loop. On the other hand, you use for loops when you just want to do the specified amount of code, like a specific number of times. So you want to ask the user the same question 5 times, then you would use a for loop as opposed to a while loop, because you're not dependent on a certain condition being reached. Does that make sense? All of that? Okay, cool. All right, so now these are some things that are specific to MATLAB. In MATLAB, every variable, unlike in other coding languages where you have like integers and char, which is characters, and strings, and all these different types of variables, in MATLAB, every variable is technically an array. Like it might look like it's just a singular letter, like Y, which represents like yes, but it's actually an array, just because everything is an array. And that's the advantage of MATLAB, because it allows you to do all those fancy matrix-related computations. An array is just an ordered collection of information that's numbered, which just means that it's like a column of information, and every value in that column has its own number. So you can essentially either call upon different elements based on the number, or you can edit an array based on like what value you want to adjust. So that gives you a lot of control over what exactly is in an array where. And indexing for an array, which just means the way it's numbered, begins with 1 instead of 0. So in like Python and C and almost every other language, you start with 0, and that's how you count. But in MATLAB, you start with 1, which makes it a little easier, I think, for beginners. And then a matrix is just an array whose elements are also arrays. So essentially a multi-dimensional array. So we'll see some of that later. I'm going to go over some syntax. So syntax is like kind of gross in that like it's gross to teach and it's gross to learn, but luckily you'll be able to Google all of these things when you're actually coding, and you won't need to worry about like, oh, do I remember exactly where to put a semicolon and things? So I'm going to go through this stuff really quickly. If you have any questions, again, stop me. But I'll also drop the link to the presentation in the chat before we move on to our like hands-on exercise. So you guys can just refer back to this if you have any questions about syntax. So with that, I'm going to just go through this really quickly. So first you have basic variables. You just define a variable as I've done here. Oops. With the variable name on the left and the value on the right of this equal sign. And you should end your lines in MATLAB with a semicolon. It's not required. Unlike in C, you don't have to, or C++, you don't have to end your lines with a semicolon, but it's good practice too, because if you don't, then every line you don't end with a semicolon is going to come up in your command window. Then your command window is going to be filled with like all sorts of stuff that you just don't want in there because you're trying to figure out, you know, what your program is doing, and so you get just all your lines of code. So yeah, this is how you define a variable. You can do some like basic arithmetic on the right, just using these different symbols. Then to define an array in matrices or a matrix, remember everything we're defining technically is an array, but if you want an array, as in like an array that actually has multiple elements as opposed to like a 1-by-1 array, which is just one value, you're going to define it in brackets like this. So essentially this is a row vector, which means that like your different elements are in a row. So you just don't need to separate it by anything. You can separate it by commas, but here I've just like left it like this. So this is a row vector that just has these 4 elements. Or you can do a column vector. Oh, sorry, you can't separate row vectors by commas, because a column vector, when you separate it by commas, it'll just come down. So it's literally just a column as opposed to a row. This is only really useful when you're taking arrays and you're trying to like, you know, do arithmetic with them, or you're doing arithmetic with them in matrices, because then the dimensions matter. A much easier way to make an array as opposed to writing it out like I did here is if you have an array that has like regular intervals, the elements are at regular intervals, you can just do it like this, where you have your start element, your ending element, and then the middle one is just how much you're going to step by. So the example here, it outputs 0, 5, 10, and it goes on from there. And then with the matrix, you're just going to essentially create multiple arrays in one set of brackets. So these semicolons will denote a separate row. So this is a 3-by-4 matrix. All right, cool. So you can do some matrix operations like we talked about earlier. Addition and subtraction is super easy. Multiplication will be automatically, it will be done element-wise. So essentially you want some constant or some value to multiply by every element of the array. You do that with just this period before it, or else you'll end up doing matrix multiplication and division. So matrix multiplication is when you multiply the inner products between rows and columns. If you don't know what that is, that's okay. We're not going to be using it today, so don't worry about it. You can take the inverse of a matrix, which is when you, which gives you the identity matrix when you multiplied with the original matrix. And then finally, you can transpose a matrix with a single quote, which is essentially just flipping the matrix. So A transposed, which is defined up here, this is just one row vector. It'll turn it into one column vector, which you can see down there. All right, now we're going on to strings and characters. Again, I'm moving super fast. If anyone has any questions, please pause me, but I'm going to take that as a no. Okay. All right. So strings and characters, again, these are all arrays, but the way for you to display text in MATLAB is to use quotes. Technically, when you're using double quotes, that creates a string, and single quotes are like characters. But in reality, you can use either and your code should work just fine. The one important thing that you can do here is concatenation. So concatenation just means to smush things together or to add them. And so when you want to concatenate strings, you can just use the plus sign, and all that'll do is just display the 2 strings put together. Or you can make it into, since everything is an array, you can use any array operation, and you can essentially add these 2 strings together by putting them into the same array. And we're setting it equal to C here, so you can then like display C or something like that. So yeah, to output a character at a specific position, again, because these are all arrays, you can just use parentheses. So essentially what we're doing here is we're looking at the array that's under the variable name D, and we're trying to select a very specific character within this long string. So we want the 3rd character, which is C. And so the way we do that is when we do D parentheses 3, that would output C. And note how we didn't put a semicolon here so that like we actually get the output in our command window, which is what we're looking for. So functions that accept characters will also accept strings and vice versa, because essentially they're interchangeable in MATLAB because they're not different data types. All right, now this is just the syntax for an if statement. There's another type of conditional called a switch statement, which is just an if statement, but a little easier to read sometimes. I explained what an if statement is, but you guys can kind of see it here. I'm generating a random integer from 1 to 100. And depending on what the integer is, I'm just displaying a word. So that's the if statements, and we're going like else if it's this or else it's this. And that's just the format. Note how an if statement ends with an end. Actually, any conditional ends with an end. So you're gonna have to do that for your code to know where the if statement ends. And then switch statement is like the same idea, except what you put here in the case is the differing inputs. So switch statements are nice when you have like a set number of inputs you know you're going to accept. But obviously it'd be a little difficult for me to put it together a switch statement if I had 100 different values. So in that case, when we have like ranges like this, if statements are easier. I'm gonna be honest with you, I've never used switch statements when I'm actually coding. So I would recommend if you're confused, just stick to if statements. I think they're a lot easier to understand. Okay, so this is now we're getting into, I think, a little more important things in terms of just how MATLAB works in general. So MATLAB code is written in .m files. So every coding language, whenever you write some code in any language, usually has like a file type that it's associated with. And that's how your computer knows how to deal with it, essentially, especially if you're just running it on your computer without an IDE. For example, Python files are like .py, and that's how your computer knows that's a Python file. MATLAB code is written in .m files, and the way you run MATLAB code is you run the .m file in your MATLAB IDE, and that's how the software essentially handles it. You can also create functions in MATLAB, and a function is essentially just a piece of code that you're going to want to reuse over and over again. And you make this in a separate file. Technically, you can make it in the same file, but I would not recommend if you're going to try to make a MATLAB function to put it in the same file, because then you're going to have one huge file with way too much code. So when you're creating a function, you're going to put it in a separate file. And a function looks like what I've done here. When you tell MATLAB you want to create a function, you like right click and click new function. It'll populate a file that looks exactly like this. So I'm going to use this to explain exactly what a function is. Because functions, again, are one of those things that come up in all coding languages, and you'll probably be coding even outside of MATLAB. So what we have on right, so this is just telling us it's a function. And what we have on here, I'm going to start here with untitled. So untitled is the name of a function. So when you write a function, you're writing a piece of code that you're going to want to use. But what makes it different from a loop, for example, is that this piece of code is going to have different inputs every time you call a function. So in your main file, you call a function by saying untitled, and then in parentheses, you put whatever arguments you want to put into this piece of code, the separate piece of code you're writing. And then in your function file, you will have this file that looks like this, that will tell you what the function name is here, untitled, which is the way you call the function, and then the input arguments. So these are the arguments that you're going to send into your file in order to generate some output. So inside the body of your function, you'll have all this code, but that code will depend on these inputs you write up here. That's a little confusing, especially all the naming. We will be writing a function today, so hopefully it'll make a lot more sense when you have hands-on experience. And then when you have a function, when you call a function in your main file, you're also going to have some output that you want to get out of the function, because that's what makes functions like useful. And when you're doing that, that's what these output arguments are. This is what comes out of the function, and it's going to go back into your main file after everything is done inside the function file. So that's what we see in here. Here, they're just saying that the input is going to become the output, and that goes back out to the main file whenever the function is called. And in MATLAB, they like have you write a little summary of the function up here, like in comments. So these are commented out. The computer does not see them, but also very important to comment all your code. So I would recommend commenting and filling this stuff out. And last thing to mention with functions, in the bottom here, there's an end. Like with conditionals, the way your computer or the MATLAB application knows that your function is completed is when you write this little end at the bottom. That's automatically there if you create a function file, but just like don't forget to do it. Do we have any questions about functions? Because that can be kind of a new concept. Give us a second. Okay, I'm going to take that as a no. But if we have questions later when we're writing a function, you guys can ask away. All right, and finally, the last cool thing you can do with MATLAB is plotting. So plotting is super, super easy in MATLAB. Literally no other programming language makes it this easier. Essentially, there's a set of functions here. For example, I have plot, title, x label, y label, legend, and they do exactly what you think you would do. Like this literally creates a plot of time versus concentration, or CONC, which is the variable I've named. This just like tells you what color you want your plot. This is the title of the plot. This is what labels the x-axis, the y-axis, and this is a legend. This is actually directly copied from what we're going to be doing later today. So you guys will be able to see what this sort of plot actually looks like when you have information in the variables. But yeah, plotting and honestly a lot of these things, like I said, you can find all the syntax online. I copy pasted or I snipped a couple of these like most relevant plotting commands and put it on here. This allows you to like, this you guys can like refer back to, especially with plotting. I feel like it's one of those things where I end up Googling every time I'm going to go plot something in MATLAB. So just keep this in mind. I have more helpful commands listed here that you guys can look at as we're coding. And just a couple of last minute things before we move on to our actual demo is that when you begin a MATLAB file, because there's stuff in the command window, there's stuff in the workspace, you want to make sure you start with this sequence of commands, close all, clear all, and CLC. Essentially, this will close any plots that are already open, clear your workspace, and clear your command window so that you don't have to worry about, you know, stuff from your previous files, like messing up in terms of variables and stuff when you're trying to run new code. And then finally, when you do use these commands, I've kind of glossed over what commands are, I guess, but essentially commands allow you to do things in code. For example, this allows you to display something in the command window. And any of these things that I have on the left-hand side in here, or even here, all of these are commands. They're essentially functionalities. Well, they're actually just functions that MATLAB already has coded in and that we can use. Every time you use any of these functions, you're going to want to put whatever your input is in parentheses, because technically these are actually just functions in themselves and you have to treat them that way. So that's how you put your input arguments. But that is kind of a lot. I'm going to, right now, I'm going to drop the link to the slides in the chat so you guys can look over that as you need to. And then I'm going to start going over the demo. So this demo will end up being just like a hands-on exercise. I'm going to explain a little bit of the science behind it, seeing as this is like a real-life BME application and something you can actually model with MATLAB. But essentially, we're just going to be using it as a way for us to get comfortable with MATLAB and learn how to code in the language. So what we're going to do is today, in the next 30 minutes, we're going to be looking at how to measure cardiac output. So all cardiac output is the amount of blood pumped by your heart in a given minute. So as you can imagine, this is one of those measurements that's probably pretty important to a doctor. It increases when you work out, it decreases when you're just sitting there like I am right now. Probably don't have very high cardiac output because your heart isn't pumping that much, but it's quite relevant if you're a doctor and you're trying to figure things out with your patient. Unfortunately, it's pretty hard to measure like by itself. So often we use other proxy measurements, I think if you're actually like in a hospital. But let's say for some reason you really wanted to find someone's cardiac output because they're suffering from some sort of heart disease. The way you would do it is you would measure so you'd inject dye into a person's, into someone's like vein. And then what you would end up doing is you'd measure the concentration of the injected dye in their blood over time in a given artery. So essentially you just sit there and like monitor the concentration of that dye coming through a certain artery. Bye, Lydia. Yes, totally recommend. I'll do some advertising for those 2 units in the IDP department at the end. But yeah, so essentially you're going to measure the dye concentration in your artery. And the way you calculate cardiac output from this dye concentration is essentially using this equation that I have copy pasted here. You don't even know the details of this equation, but essentially what's important here is that we have an integral at the bottom. This is the integral of the concentration of the dye over time. And we're going to need to know the value of that integral, but unlike like in math class where you'll be giving an equation where you can solve for the integral, in like real life and in engineering, you're often going to be given a bunch of data points and you're going to have to find the integral from these data points. So I'm sure you guys have learned in class, like even in high school, there are ways to do this through like rectangular approximations and trapezoidal approximations. But today we're going to use something called a Simpsons approximation, which is just this fancy equation that allows you to approximate the area under a curve. So essentially what we're doing in our demo today is we're going to be implementing this code to solve for the area under a curve or the integral using the Simpsons approximation. And then we'll use that to solve for cardiac output and we'll be able to actually see like a pretty little graph of concentration over time. So that's what we're going to be doing today. So before I move on, because right now I'm going to switch to MATLAB and we're going to actually start coding, but does anyone have any questions? Okay, I'm going to take that as a no. All right, cool. So give me a hot sec while I switch over. Okay, so right now, you guys, if you're going to be doing the demo with me, should also open up MATLAB so we can kind of get started together. Hopefully everyone downloaded the files I sent out in the email yesterday? If someone didn't, please let me know, or download them now, ideally. Okay, cool. Can everyone see my screen? All right. So what I'm going to do right now is so what I've done is I just opened up MATLAB. And in MATLAB, I have a folder called Live Demo, which is under a bunch of other folders. But essentially, this is the folder I'm going to be coding in. And in this folder, I've already uploaded 2 of the files I'm going to need for this for the code I'm going to write. So I would recommend you guys do the same as well, because or else your code is not going to be able to run. I sent out 4 files, but of the 4 files that I sent out, 2 of them are the cardiac output.m and die data _2020.txt. So the die data is just the data we're going to be using, the concentration data we're going to be using. And cardiac output is just a function that I coded that essentially calculates cardiac input based on the integral. So what we're going to be doing today is coding the main file and then coding the file that allows us to use the Simpsons Approximation code for the area under the integral. So do you guys have these 2 files up on a folder on MATLAB? Are we having any problems with that? Because I know that can be, if we don't have that working, nothing else is going to work. Okay, Celine nodded her head, so I'm going to assume everyone's okay. But if you're not okay, please let me know. Because like I said, nothing else is going to work. But since you guys seem okay, I am going to now create a new file in MATLAB. So the way I do that is I go to my current folder, which is the current directory. That's what this area is called, current directory. And I am going to right click, and then I'm going to click new or scroll over new, and then I'm going to new script. So this is if you just want a plain old MATLAB file to be generated, not a specific function, like nothing fancy, you just want a file, you're going to click on script. And see it popped up on the left-hand side. This is my new MATLAB file, and I'm going to call it die dilution main, because this is going to be my main file. This is the file I'm going to run when I want to get my answers at the end. And this is also the file that's going to call the other functions and put inputs into them and then get outputs from them, and in order to calculate our final results. Then I double clicked on die dilution and it opened up my plain old empty file. Are we all comfortable with this so far? Okay, cool. So I'm going to do exactly what I said I was going to do at the very beginning, clear my workspace. So that just clear all, close all, and then CLC. So this is just to make sure I don't have anything else open. I don't, but just in case I did, that you're going to start off with this. And then to run your code, now this is not really going to do anything, but just to show you guys, to run your code, you click run at the top. And we can see down here for a hot sec, it produced die dilution main because it's running the main folder, or main file. Are you all okay with that? Cool. All right, so right now I'm going to load the data in. Technically, even though my data is sitting in my folder here, it's not in this like program for the program to be able to like read in the data and stuff like that. So in order to load data, we're loading it from a txt file, so we can just use the function load, and then I'm going to put in the name of the file. I'm not sure if you guys renamed the file. If you do, then you won't be putting in the same name I am. But essentially all I did is I took this name, die data _2020.txt, and I'm putting it here. What this is going to do is it's going to take a variable, it's going to create a variable called die data _2020, and it's going to save everything that's in this text file. .txt stands just for a plain text file, and put it into that variable. So if I run this, we see that it worked, because in our workspace, we have our die data variable that got created, and it's a 34×2 double. So a double just means an array with 2 columns. And that has exactly what's in our txt file. If you were to open up our txt file and open up here, if you want to open up a variable, you just have to double click it and I'll show you what's exactly what's in that variable. So this is what's in the variable. These two match now because we've loaded our data onto our program. Okay, cool. So now that we have our die data, what we're going to need in order to solve this equation is we're going to need to know the initial amount of dye that was injected into our patient, whose data we are taking. So the way we're going to do that is we're going to want to take just the first element of the first row because that has our injection data. It has this, I'm telling you that because I know that it has that, but in reality, you probably have to look at your data and understand that it has that. So I'm going to name a variable. So this is going to be, I'm commenting everything. You guys should also be commenting everything. I still have no idea what happens later when you're trying to come back to your code. So I have a variable called die_inject, and all I'm going to do is I'm going to take my variable I created with the data, and I'm going to pick the first element of this data. So this first one stands for row number 1, and the second one stands for column number 1. So that's how you, in general, in anytime you have a matrix, you're going to pick a very specific value. When you have the index meaning the number that's associated with it, like the ordered number, you do row by column. So this is the row by column that corresponds to the initial dye concentration, and I am going to just assign it to this die_inject value. So that works. You understand that it's 8. I don't remember what the unit of 8 is, but it is 8, probably like millisomethings inside your blood, some unit of concentration. But it'll all work out, I promise you the equation. So now that we have our first initial concentration value stored, we don't need the first row of our data because the first row of our data is just going to have the initial values. So hypothetically, you could take it out. Let me see if we should take it out. It seems like I leave it. Oh, I don't leave it. Okay, yeah. So there are 2 ways you can do this. You can either take out a row of data completely, which we're not going to do, or what you can do is you can just take the relevant data you want and put it into separate variables so they're easier for you to use later. So right now I'm going to create, when you look at this variable, here, let me explain this .txt file a little, or this variable now a little. This first row, ignore the first row, but the first column is essentially just time data. So this is data over a given amount of seconds, essentially. And the second row is the concentration. So we start off at 0 concentration, and then as soon as the dye is injected, as it increases, and then it decreases over time, obviously, because the dye just gets like diluted as it circulates through the blood. So we want to take the time column and the concentration column and store them in separate variables so that we don't have to worry about trying to go through die data underscore 2020, which is an annoying large matrix of a variable, and take that. So what we're going to do is we're going to have to find some way, essentially, to take all the values that are right here and store them in a separate variable, because we don't want the first row. The first row has our initial information. We don't want it. And we don't want the second column because we don't want our concentration information. We only want our time information. So we're going to do that is we're going to go from 2, which is from row 2, all the way to the entire length of dye data. And that's going to be the row values that we want. And then the column we want is going to be column 1, because column 1 is our time concentration column. Does this make sense how I did this? The column is just going to give you all the values in that matrix or in that array in between the 2 values you specified. So this is like start and this is stop. Stop being the entire length of the column. Does that make sense? Okay, cool. So now I'm just going to copy paste the same thing for concentration, because the only difference is that we have a new variable named concentration and we're doing the second column. Are you okay with that? I'm going to zoom in. And then just for our data, we're going to need a time interval. This is just what we're going to need for calculating again. And the way I'm going to create a time interval is just by taking the first time value and subtracting it from, sorry, the time interval is the time interval in between the measurements. So I'm just taking a given measurement and subtracting it from another measurement. So I'm taking the second measurement and subtracting it from the first one. Note how, now that I have an array only has 1 dimension, I'm allowed to specify the index of the value I want without using 2. I don't have to specify a row and a column. I just use 1 variable or 1 number, which is just the row, or in this case, just the column number. So I want the second element and I want to subtract it from the first element. Does that make sense? Now that we're moving on to arrays. life is a little easier. Okay, cool. All right, so now we've loaded our data and we have defined the variables we need to. So what we're going to do is we're going to go ahead and we're going to move on to coding the Simpsons approximation right now. So I am going to, the way I'm going to do that, I'm going to create a function. So this time I'm going to go to new. I right-clicked in the command directory and current directory. And then I went to new, and then I'm going to go to function. And see how this looks a little different? You can tell it's a function as opposed to a plain MATLAB file. And I'm going to name this Simpsons. Oops, I misspelled that, unfortunately. But it's important to spell these correctly so that when you call them, you don't have the wrong thing. So when you open up Simpsons, you have, or any function, you have exactly what I had in the slides, essentially. A file that has a function, and it kind of, MATLAB fills in a lot of stuff for you. See how it already, oops, see how it already puts Simpsons down as the function header, I believe this is called, function name. So this is exactly how I'll call the function using this name Simpsons in the main file when I want to put in something and get something else out. So when I want to put in the time and the concentration data so I can get out the area under the curve. So the solution for the integral. Does that make sense? That's how you have input and then you have output. So what we're going to do is for our Simpsons approximation, what we're going to need is we're going to need concentration data, and we're going to need the interval, which is the time interval. I'm purposely naming these differently from the way I've named them here, so you guys can see how that works. But essentially what's going on here is the names I give these variables in here is what they're going to be named locally within this function. So in my main function, concentration, it still goes by conc, C-O-N-C, and time interval, which I here have defined interval, still goes by T interval. But inside this function, I can refer to them with these names. So in reality, it would be easier for me to use a shorter name here, so I don't have to type out these long words, but I'm just using something different so you guys can see. Does that make sense? Okay, cool. And it's going to output some integral value that I'm going to call integral. All right, Simpsons, there should be a summary of the function here. I am not going to add that for time's sake, but if you're actually coding, obviously you'd add comments to describe what your function is all about so people understand your code. When you're actually coding something, you'll probably have like tons and tons of functions, so it's helpful for you to fill this in with actually what your function is doing. So the way the Simpsons approximation works, if we are to very quickly, okay, wait, I'm not going to go back to my slides. But essentially, if you looked at the slides and you look at the equation, it's an equation where half of the data points, half of the data points are multiplied by a certain value, and the odd function, or the odd numbered points in our like data array are multiplied by 2, and the even elements are multiplied by 4. And then you plug those those numbers multiplied by their either 2 or 4, depending on whether they're odd or even, into this equation, and that equation outputs the integral essentially. So the tricky part here is finding out which elements are odd and which elements are even, because there's not a function, as far as I'm aware, in MATLAB that'll just output the odd elements in an array for you. So you have to kind of figure that out by hand, and that's where actually matrix multiplication, or the way MATLAB is built, is super useful, because I don't really know if you can do this in a lot of other programs unless you download like a bunch of Python packages or something. So essentially what we're going to do is first I have this here. I'm just going to copy paste this part. I'm going to, in this if statement, so the reason I'm doing this if statement is because the way the equation works is technically the way we're coding it here only works if you have like a odd number of data points. So what I'm saying here is if mod stands for modulus. So modulus is just remainder. In coding languages, for some reason, they never refer to things as remainder when you're dividing something, but it's called modulus. So if the modulus of the length of the concentration array and 2, so essentially the length of this concentration array divided by 2, if it's 1, so essentially if it's odd, then you can enter this if statement. So essentially the way we're going to be programming this only works if you have an odd number of data points. Luckily, I've given you a text file that has an odd number of data points where code will work, hopefully, we will see. But if you have an even number of data points, actually have to code this a little differently, and it's a little more difficult. But we're just going to start with this. Assume you have an even number of data points. So what we're going to do is we're going to want to get just the odd data points. So how we're going to do this, what I'm going to do is I'm going to write down exactly how to do it, and then I'm going to explain step by step what this does. Because it's a bit spiffy. It's slick, as Jennifer Truitt would say. The way MATLAB works here is that you're going to, what we're doing here is it's kind of what I explained in the slide. So we're going to start, stop, and then some incrementing value in between. So we're inside of the concentration array. We're trying to select the certain data points that are odd, right? So what we're going to do is we're going to start on the third data point because we didn't want because the way the equation works, you don't use the first or the last data point. But we're starting on the third data point, and then we are going all the way until the length of the, sorry, I realized I'm naming this wrong, the length of the entire concentration array. So we're going to go from the third data point all the way to the end of the concentration array, and we're going to go with every 2. So essentially what we're doing is within the concentration array, we're selecting every other point, but they're odd because we're starting with 3. Ooh, I have something in the chat. Oh, someone has to go. All good. All right, cool. So does this make sense? How I'm selecting like every other data point, but I'm starting at 3. And therefore,
I have a question.
Yes.
What's the minus like 2 thing, the end?
Okay, yeah, so what we're doing here, for some reason, the way I coded this back when I was coding this was that I started with a third data point and then I went -2. So it actually started at the first data point and then didn't include the last data point. The reason I did this is because it's a lot easier to know where you start and then go till the end. Because I know I'm going to start at 3 and then go till the end, as opposed to start at 1 and then go up to some value -2. The way I could have done that is I could have done that at 1 here, because you're going to start at 1, go every 2, and then I would have done length of concentration itself -2. But the way I just coded it was that I started at 3 and then I shifted it back. Because right here, all we're doing is we're selecting the index value as opposed to the value itself. Does that make sense? Okay, cool. That is honestly the hardest part of what I'm teaching you guys today. Note how, I just want to make a big point here. If you were coding this in another language, you would have to put in like a loop, like a for loop, and go like for every I value in between 0 or in between 3 and the length of the concentration, going every 2. And then inside that loop, you would have to say, add to the array S odd, the value from the concentration. Essentially, you'd have to do a really long for loop. That's an iterative process, meaning that you would have to run that loop over and over again until the length of the concentration is over. Because the only way you'd be able to access getting every other point is through a loop. But MATLAB allows us to not do a very time expensive and computationally expensive loop by doing it like this, where we can just select every other point because we can count through the array like this in a very, very neat little way that makes life easier for us. Does that make sense? Because I think when you first look at this and you're trying to code, your instinct, or my instinct at least, is to write a loop, but you don't have to write a loop, and you shouldn't write a loop because the loop is far more expensive than just writing it like this. So that's sort of important to know. That's like what you can do with MATLAB that is cool. And also, I mean, that's what gives it an advantage over other languages. So now I'm just going to multiply it by 2 because I'm supposed to. And then I'm going to do the same thing for S even. S even, I'm going to just copy paste it. And S even, this time I'm just starting with 2. I want even numbers. And then I'm going to take S even and I'm going to multiply it by 4. So note also when I multiply it here by either 2 or 4, it's multiplying every element in my array. So, which is kind of cool, because then you don't, it's not doing matrix multiplication essentially, but it's multiplying the constant by every element. Okay, cool. And then we just calculate the area under the curve based on this equation. I'm just going to copy paste this because this equation is not particularly relevant to us learning how to code it. Essentially, all it does is it uses the time interval and it uses the values from our concentration array, and it essentially just puts it into the equation that was provided to us. So yeah. So this will now give us our integral value. Unfortunately, because up here we do have an if statement where we said this only works if we have an an odd number of data points, we're also going to write a else statement because Let's say for some reason you're given data that has an odd number of data points, or sorry, an even number of data points, and then your code would break. And the idea is to code well and to code like robust code, you should make sure it doesn't break. So it handles as many edge cases as possible. So you're gonna write an else statement here where we just display an error if for some reason they give us an even number of data points. That's really easy. There's just a function called error that we write. So if we were to give this code data, it would just pop up an error in the command window for the user, and the user would know that isn't right. Because a function always has to be outputting something, when it says it's going to output something, it has to output it. We're going to just say that the integral is going to be 0, and that's just part of the error. Obviously, this isn't actually handling the problem where if you have an even number of data points, this doesn't actually like solve anything. It's just like a way of sidestepping the entire problem and like blowing it under the rug. But for our intents and purposes, this is okay. So yeah, this is good. We can remove this because integral is our output and we are already setting it equal to different values. So when we call this function, there will already be an output, which is awesome because that means here we can go back to our main function. So I'm back on the main function now. And I am going to create a variable called Synth Integral. And that is going to be our integral, the results of the integral when we call the Simpsons function. So the way you're going to call the function is you write Simpsons because it's called Simpsons up here. And we have it called that here. And then we're going to put in the different arguments that are needed for this to run. So the time interval and the concentration. Note how you have to have the same amount of inputs here as you do here. There is a way for you to put in like optional inputs and things like that, and then like be able to read in like the number of inputs we have into a function. But for now, I think this is okay. We're just gonna, we have 2 inputs and we're assigning them here. And then we can display the integral that comes out. And let's see if it actually runs. Let's hope this runs, because if it doesn't run, that would be unfortunate. There's an error. What did I do wrong? Okay. The nice thing about the command window, is that it'll tell you exactly what the error is. And if you're confused, go to the line number. I'm sure even if you click it, it would go to the line for you. Yeah, it does. It goes to the line for me and tells me exactly what my error is. So that's really helpful when you're debugging for you to check that when you, oh, I shouldn't have changed the name of these things. Now it's, I have comments, emails. Okay, hopefully it's enough. Yeah, okay, great. So now it ran, and this is our value. This is the area under the curve for the dye dilation curve, which is super cool. So now we can see that. And now what I'm going to do to solve for the cardiac input, I am going to call the cardiac output function. So we already have a cardiac output function here. Let's just take a quick look at it. This is a function called cardiac output. It outputs CO, which is the cardiac output, and it requires the initial concentration, dye inject, and the integral value that we just calculated from Simpsons. So we are going to call that output, so that function, using the function header that we have. And see here, MATLAB will already tell you exactly what you need to put in. It tells me I need to put dye inject, which looks like and then I need to put in the integral, which I have to use, again, I have to use the variable names that have given the variables in this main file so that it'll read the correct variables, as opposed to, I can't use the values I have in here because these are only local. These are only locally assigned, these variable names, to this function, whereas these are the names for the main function. It's like a subtle difference. Hopefully that makes sense now that we're running the code a little. So that function worked. That's great. We can look at it and see how it works. I believe MATLAB is case sensitive, so you should watch that. Great. So we got the cardiac output for this patient. Apparently it's 8.7 liters per minute, which sounds like a lot, but maybe this guy's really exercising, which is good for him or her. So now finally, we are almost done and we only have 5 minutes left, so that's good. We are going to plot the curve. So we found our answer. Technically, if this was like an assignment or something, your answer would be the second value. And you'd probably display it like nicely. For example, the way I display it in the code, if you guys can see, for the integral is I use like a string, like the way we described, and I use plus signs to concatenate the different strings. Because everything is an array, you can just concatenate things without worrying about the fact that technically SCO, oops, this is in the wrong spot, without worrying about the fact that SCO is technically like a number and you have some text here. Everything should work. And when you run it, it just puts it all together in a nice output that displays in your command window. Now, finally, we are going to plot. One thing I want to mention, when you do two percentage signs, it actually kind of subdivides into another section, which can be nice when you're trying to code and you want your code to look nice. So it's not percentage. This is. We're just going to plot the data we have. So in order because we're running a little short on time and I want to have a couple minutes for questions at the end, I'm just going to copy paste. This is from the sample code I gave you guys, but it's the same thing I showed on the slides and I kind of explained it there. So I think we're okay. Essentially, all this is going to do is plot our data, time versus concentration, and it's going to give it a bunch of labels. These are all just lines of text that I put in. And then finally, it's going to set the axis range. So essentially what this does is it says the x-axis is going to go from the value 0 to 45, and the y-axis is going to go from the value 0 to 15. So that's in its own array inside this axis function. And so when I plot this, the only other thing I want to say is this makes sure that it's plotted in black circles. So when I run this, for example, you will see if it works. Let's give it a second. Can you guys see what just popped up on my screen? No. Okay. Okay, here, I'm just going to stop share and share again really quickly so you guys can see. Can you guys see it now? Awesome. So these are black circles. That's what was specified by this OK here. But essentially, this is our graph. So this is the concentration of the dye through this person's given artery over time. And we can kind of see it takes about 40 seconds for it to completely die down or for all the dye to get dissolved or diluted in the blood. And this area under the curve is what we just calculated with Simpsons and from which we got a cardiac output. But yeah, that is all I have for you guys today. And it looks like we're finishing right on time. Do you guys have any questions about anything, especially that plotting stuff at the end? I kind of fast forwarded through that, but I think it's self-explanatory. Any questions about MATLAB at all? It doesn't even have to be related to this application. It can be just about like MATLAB in general. Anything from the section.
I have one question. It's kind of just general, but like in my BME labs and stuff, like it can get frustrating, like having like a ton of errors. So just like, what's some like advice for like getting through that, just like debugging and everything?
Yeah, for sure. I think one thing that helps me a lot is looking at that workspace area on the left-hand side when your variables are set. Sometimes you'll notice that like some variables aren't being generated or they're generating like random numbers. And that's when you know that something is going wrong. And then you can see where it's going wrong because it's going wrong where that variable was assigned to a value last. So kind of just working backwards. And I think going through that is super helpful. Also, since if you have like a really big data set and you're trying to like understand what's in the data set and you don't really know what's going on and that's where all your errors are coming from, just opening it up on MATLAB will help you see how MATLAB reads it. I've had cases in the past where I'll read in CSV files and CSV files sometimes have like empty columns and stuff at the end. So MATLAB is reading way more columns than are supposed to be there. And I need to do something with that, but I didn't know because I didn't see those columns when I was like obviously looking at the CSV file. So I think starting with that, with the workspace and then going from there is super helpful. All right, cool. Any other questions? I'm gonna stop recording real quick.